2019 Exam 2 Recursion and Financial Maths, Question 8. Phil invests $200,000 in an annuity. That's a difficult thing to say 3 times fast. We got the A naught there of 200,000. He's got regular monthly payments, and we want to know what those monthly payments are. It's just that number. Apparently lots of people overthought this. It's just $3,700. That's what you're taking out each time, so that's why there's a minus for the takeaway. Lots of people apparently said $3,000 or gave the answer to what was actually part D, which we'll do in a minute. Now we're going to show that the annual percentage compound interest rate is 4.2, a self-answering question. Now, if you look at this number here, the 1 is the principal, and the other part, everything else after the decimal, is the interest rate, little r. So what you got to do is you say 1.0035 minus 1, because you got to subtract the principal. We only want the r part. You've got to multiply that by 12 because there's 12 months in a year, and multiply by 100 because we want to make it a percentage, and that does equal 4.2%. PA per annum. Fairly straightforward again. Apparently basic arithmetic errors, and some people trying to work backwards, just straightforward like that. Okay, now we've got to find out that what is the balance of the annuity when it first falls below the monthly payment amount, so below 3,700. Round your answer to the nearest cent. You could do that thing where you press the button on the calculator. So you could put in 200,000, and then you put in the recurrence relationship here, which I've shown here. And when you do that, and you don't have to count anything here, it just wants to know what the value is. So you could just press execute over and over again. And that's one way to do it. And you can see here, many times, that's above, that's below, that's the first one below 3,700, 3,700. And so you've got to round your number again, rounding. The 5 looks at the 3. The rest of it doesn't matter. 3 says stay on the floor, so it is $92.15. I think that was actually the easiest way to do it, was just put the recurrence relationship in and hit your calculator. It's a bit confusing wording when, first falls below the monthly payment amount. I mean, you have to get part A right to get the rest of it right. Next part, part D. If the payment received each month by Phil had a different amount, it would act as a simple perpetuity. That means that every single term is going to be 200,000 because it doesn't change. 2 ways to do that. You could just do 200,000 times the 0.0035 because that's the monthly interest rate. And you would get $700, which is the answer. You could have put it into your financial solver if you're having a bit of a panic attack. Remember, with a perpetuity, any number is fine here. Any number you like. I just put 1 in, any number. We already got the 4.2, minus 200,000 because you put the money in the bank, positive 200,000 because you're going to have 200,000 exactly the same at the end, and 12 and 12 because that's what we're doing, and you'll still get the 700 there. 2 ways of doing it, fairly easy. Yet only 40% of people got that right. And part C was even worse, only 36% of people got that right. Again, rounding, people learn to round.